Determine the largest shearing stress in section NN, which we see right here. The shearing, NB, the shearing stress at point A. Okay, and point A is right here. Okay, let's do a couple things. First of all, we need to find what the shear stress, what the shear force is at NN. So we need to find the reaction forces, and this is symmetric, and we don't see any concentrated moments, so it is truly symmetric. 20 and another 30, that's going to be 50, so that's going to be 25. And so now we can actually kind of draw the little thing here, and you'd see if this is 25 and here V1, so V1 is equal to 25 kips. And so now we have our V, and that's the shear force. Now we can find the largest shearing stress in the section by knowing that the largest shearing stress occurs at the neutral axis. The neutral axis is right here, so this is where my largest shearing stress is. And now we can say that T max is going to be equal to VQ over IT. Now we just found our V, which is 25 kips. I don't know why I keep doing that. I think there's a better way, and I'm going to show you. Instead of recoloring that, I can do this. There you go. And so that's going to be my V. And now Q is going to be from the neutral axis all the way. So this whole thing is my Q. This and this. Right? So where is my neutral axis? So my Y is going to be at 10 divided by 2 is at 5 inches. I don't even need to write it here. I'm going to just put it in the figure. So this is going to be at 5 inches. And then we can decompose this into these two portions. And so my Q is going to be equal to the area of the first one times 10, the top one times 10. So 1 times 10, 1 times 10. And no, be careful, it's not 1. It's 0.6 times 10. We're looking at this distance right here. And how far is a centroid from the neutral axis? Well, the neutral axis is at 5. And what is this distance over here? That's 0.3. That's where my centroid here is. So 0.3. So we're going to do 5 minus 0.3, which is 4.7. So times 5 minus 0.3. And that's going to be the first part of my Q. The second part of my Q is going to be 0.375 multiplied by, what is this distance now? Well, we know that it is, let's see, 10 is the total thing. Then we subtract 1.2. So 10 minus 1.2 divided by 2. That's going to be our other side, our height of this rectangle. And then we got to multiply it by where the centroid of this is going to be, which is going to be at halfway of our height. So at 10 minus 1.2 over 4. Okay? Well, now we can simplify some stuff right away. So if I subtract 1.2, I get I get 8.8 divided by 2, so that's 4.4. 4.4, and this is 2.2. And so now this is 4.7. And so we get Q is equal to 6 times 4.7 plus 0.375 times 4.4 times 2.2. So 6 times 4.7 plus 0.375 times 4.4 times 2.2. And we get 31.83. So that is 31.83. 31.83. So that's inches to the third. Now we want to find our I. So what's our I? Our I is going to be, for the three shapes, oh my gosh, this is going to be long. So the first shape is going to be, the first and second shapes are actually going to be the same. So top and bottom is going to be 0.6 times 10. That's my area. Well, we want 1 over 12. What's my height? This one's cubed. Everything times 2. Hold on, I gotta take it and move it to the neutral axis, which is gonna be 4.7 squared, and its total area, which is 0.6 times 10. So we take all of that, close it, multiply by 2, and then we're gonna add the 0.375. We multiply it by 8.8. That's my area, and I don't have to shift it. My height, though, it's cubed. So this should do it. All right, I tend to always make a mistake on this one. So, open parenthesis, 1 over 12 times 0.6 to the third times 10 plus 4.7 squared times 0.6 times 10 times 2 plus 0.375 times 8.8 not squared to the third divided by 12. What I get is 286.7. 286.7 inches to the fourth. And now, what's our thickness? What's our thickness T? Our thickness at the center is going to be 0.375. So thickness, not tau, thickness is 0.375 inches. So now, my tau max is going to be equal to my 25 kips. Nope, wrong color. Times Q, which is 31.83 inches to the third, divided by 286.7 inches to the fourth, times 0.375 inches. And so we get kips over inches, which is KSI. So we get 25 times 83 divided by 286.7 times 0.375. We get 7.4. So this is 7.40 KSI. And the shearing stress at point A. So for the shearing stress at point A, that's going to be a small little thing. So we'll do that in part B.